Hey guys, it's Eddie the Magic Monk. We have already done a few binomial distribution lessons. So in this third lesson, we're going to talk about how to solve problems that involve using the formula multiple times. So let's just get straight to it. So here's the question. A bag has 7 red balls and 3 green balls. If 8 balls are drawn with replacement, find the probability of obtaining at least 7 balls. Forgot something. Of obtaining A at least 7 red balls and B less than 7 red balls. So to get this worked out, what you need to do is firstly define a few things. And that is N is going to be 8 because we are drawing 8 balls. Every time we draw a ball, we put it back. So the next time we draw the ball, the probability of getting red is the same. And the probability of getting red is 7 out of 10 or 0.7. Probability of failing to get red, so that's probability of getting green, is 0.3. And what else do we need? PQ. So the first problem we're going to solve is the probability of getting at least 7 red balls. So the probability of getting, so let's say X is equal to number of red balls drawn. Right, so the probability of getting X is at least 7, so bigger than or equal to 7. That will be equal to the probability of getting 7 red balls plus the probability of getting 8 red balls. So if you're having trouble understanding that, let's go back to drawing the table of values. So if you guys remember, these are the possible results from our experiment because we're drawing 8 balls. So the most number of red balls we can have is 8 and the least number of red balls we can have is 0, right? So we are drawing 8 times. What is the probability of getting at least 7? So we've got to work out what this probability is and what this probability is, and we're going to add them together because that is the probability of getting at least 7 red balls. So probability of X equals 7 would be, if you guys remember the formula, it's NCR P to the power of R Q to the power of M minus R. Now N is 8 and we want 7 out of 8. The probability of success is 0.7 to the power of 7 times probability of failure, which is 0.3 to the power of 1. So put that in the calculator and you'll get 0.19765. If you guys don't know how to type this in the calculator, please look at our previous lesson. And then probability of X equals 8 would be 8C8, 0.7 to the power of 8 times 0.3 to the power of 0, which 8C8, that's just going to give you 1. So this is basically 0.7 to the power of 8. And that's 0.057648. So adding these two numbers together, probability of X being bigger than or equal to 7 equals adding them together, and you will get 0.2552981. Okay, so let's go back to our second question, and that is, what is the probability of getting less than 7 red balls? So in other words, we want probability of X being smaller than 7. And you can see here in our table, we've got the probability of x being at least 7. These two boxes, we've got that figured out, and that adds up to 0.2552, or just say 0.2553 rounded up. So that's what this section equals. Now we're trying to find out x being smaller than 7, so that's this section. Now from the concept of probability distributions, you'd know that the probability of the whole sample space, all of this must add up to 1. Add up to 1. So therefore, whatever is in this section here, x plus this must equal 1. So we can just say the probability of x being smaller than 7 is the probability is 1 minus the probability of x being bigger than or equal to 7, which is 1 minus 0.25529.801, and the answer is 0.7447. Okay, so that is my answer. Thanks for watching, guys. See you next time.